For question 4, I treat database failure as a business continuity issue for Costello, not only a technical issue. Costello currently relies on Google Sheets and emails, but the proposed dedicated database will manage important data, such as customers, invoices, suppliers, and stock. Once the stores rely on this database daily, any database failure could interrupt the sales, stock checking, procurement, and management reporting. Therefore, Costello needs recovery techniques that are both fast and accurate. Costello faces two different types of database failure with different recovery needs. The first type is logical transaction of software failure. This threatens data consistency. For example, an invoice update may fail halfway, a stock movement may not be fully recorded, or customer spending history may become inconstant. The second type is hardware or site failure. It threatens data availability. For example, the database server may fail, a disk may crash, the store network may be unavailable, or the sync of the system may go down. These two failure types require different recovery approaches because one mainly affects data integrity, while the other mainly affects data access and availability. The first failure type is transaction failure. In Costello's database, a sale should be treated as a complete transaction, not a group of separate menu updates. For example, when a customer makes a purchase, the database may need to create an invoice, record invoice line details, update customer purchase history, and reduce stock quantity. If the software of connection fails before all updates are completed, the database may become inconsistent. One table may show that a sale occurred, but another table may not show the correct stock movements. This can lead to inaccurate reports, wrong stock decisions, duplicated manual checking, and a lower trust in the new database system. For transaction failure, Costello should use transaction integrity, journalizing, checkpoints, rollback, and a recovery manager. Transaction integrity means that the related updates should either or be committed together or be cancelled. This prevents half-completed transactions from staying in the database. Journalizing keeps transaction logs, including before images and after images. Before image record data before the change, while an after image record data after the change. Checkpoints synchronize the database state and the transaction log at the regular points. Even invoice update fails, rollback can use the before image to reverse incomplete changes. The recovery manager then returns the database to a constant state where only committed transactions remain. The section failure type is hardware or site failure. This is different from a transaction error because the live database or storage may become unavailable. Examples include a server crash, disk failure, network outage, office system outage, or database corruption. For Costello, this could have a serious operational impacts. Store staff may not be able to access customer or invoice data. Stock information may become unavailable, making it difficult to check product availability or reorder items. Procurement decision may also be delayed. Therefore, the main recovery need is to restore access to reliable copy of database as quickly as possible. For hardware or site failure, Costello needs a structured backup and a recovery plan. A full backup should copy the whole database periodically, such as weekly, incremental, or partial backups should copy change data more frequently, such as daily. Backups should also be stored securely off-site so the database can still be recovered if the main office system is damaged. Disk mirroring can reduce downtime by maintaining an identical copy of the database. If a database must be restored from backup, roll forward recovery can apply after images from transaction logs to restore committed changes after the backup point. This helps Costello reduce data loss and return to normal operations more quickly. Recovery works best when it managed as part of the regular database administration. Costello should not wait until a failure happens before thinking about recovery. A good DBA approach includes prevention, access control, backup planning, audit trails, and restore testing. For example, user roles and the privileges should limit what store staff, finance staff, and the managers can change. Authentication, encryption, and integrity controls can help protect sensitive customer and business data. Backup schedule, checkpoint frequency, and recovery responsibility should be documented. Most importantly, restore protocols should be tested regularly because a backup is only useful if it can be actually be restored during a real incident. To conclude, Costello should plan for two likely database failure types: logical transaction or software failure mainly threatens data consistency. It should be recovered using transaction integrity, generalizing, checkpoints, rollback, and the recovery manager. Hardware or site failure mainly threatens data availability. It should be recovered using for and incremental backups, disk mirroring, secure offsite copies, and the roll forward recovery by matching each failure type to the right recovery techniques. Costello can protect both data integrity and data availability. This supports reliable store operations and a stronger business continuity.